All right, moving on to the next type of FRQ. This is type number 6, differential equations. I don't know why, but I've always enjoyed differential equations and solving them. But this is something that pops up quite often, that it gets its own category here. So these are the problems that we're going to focus on. One thing that you see a lot of when you're dealing with differential equations in an FRQ is you'll often see them tied to slope fields. So you'll usually have a part that deals with slope fields and another part that says solve the differential equation, and maybe another part that says find a tangent line or whatnot. But the main point is differential equations. It's usually 5 or 6 points of the free response question. So with that said, let's go ahead and talk about an example through our introduction. We're going to look at number 6 of 2013. This is a non-calculator problem. So let's go ahead and do this one together and see how we do. Number 6 says consider the differential equation dy dx equals e to the y times 3x squared minus 6x. Let y equal f of x be a particular solution to the differential equation that passes through the point 1, 0. All right, right here, when you hear the words particular solution, you're thinking somewhere along the way you're going to solve this thing. You're going to get y equals out of this. Just make sure you're doing it in the right place. We see that prompt up there and we think automatically, okay, we just got to solve for y. Well, read what it says and see what it's asking for before you actually do that. Because in part A, you're not doing that at all. It says write an equation for the tangent line of f at the point 1, 0. So we're looking for a tangent line. To find a tangent line, you need two things. You need a point and you need a slope. Well, fortunately for us, we have the point. The point is 1, 0. The only other thing we need is the slope. Well, how do you find the slope of a tangent line? The slope of a tangent line is the derivative. Now, this is why I said earlier on, it's a good idea to make sure you understand Leibniz and Newton form. We get so wrapped up in Newton's form. Well, what's derivative? Derivative is y prime. So if I have y, I just take y prime and I'll have my slope that I want for my tangent line. But you notice here that in this prompt, the given information says dy dx equals. Dy dx is just another way of saying y prime. So this is our derivative function or derivative equation, and we are looking for the slope of the tangent line. So all we have to do is figure out the value of this guy at this point. Now this is unique because we have an x and a y in our equation, but that's okay because we have an x and a y to plug in there. So the first thing we need to do is figure out what dy dx is at the point 1, 0. So we'll just plug those points in, or those coordinates in. We get e to the 0 times 3 times 1 squared minus 6 times 1, and then we simplify it from there. E to the 0 is just 1, and then we get 3 minus 6 on the inside, and that all simplifies to negative 3. So there, we have the slope of our tangent line. We have the derivative at that point. So our tangent line is just going to be y minus 0 equals negative 3 times x minus 1. And that's it. We're done. That is the equation for the tangent line. It did not say put it in a certain form or anything else, so we can just leave it like that. Now, it says use the tangent line to approximate f of 1.2. Well, just as a level of comfort, when we're talking about linear approximations, we usually call our function or our tangent line L of x. So I'm just going to rewrite this equation as L of x. So all I did was replace y with L of x, and I distributed the negative 3, and the minus 0 just goes away. So the linearization, the tangent line, is negative 3x plus 3. And we're trying to approximate f of 1.2, so we're just going to plug in 1.2 to the x value and simplify it from there, so we get negative 0.6. And as a result of that, we can say f of 1.2 is approximately negative 0.6. And again, it's an approximation for the function. It is the value of the tangent line, but it's approximation for the function. All right, you would get 1 point for finding the slope. So basically knowing that you plug 1, 0 into your differential equation and then get negative 3 out, that's 1 point. you would get 1 point for the equation of your tangent line, so 1 point for this guy, and then you would get 1 point for your approximation, so 1 point for the negative 0.6 as a final answer. All right, for part B, here is your differential equation that you're solving. It says find y equals f of x, the particular solution to the differential equation. So we are looking for what y equals. Remember, the first step in solving a differential equation is to separate the variables, is to get all the y's on one side and all the x's on the other. To do this, we're going to divide by e to the y, and we're going to multiply by dx on both sides. So we end up with 1 over e to the y dy equals the quantity 3x squared minus 6x dx. Now, from here we would integrate. Now, if we go to integrate, some students might think, oh, it's 1 over something, so it must be natural log. No, remember, if it's 1 over something, if the antiderivative of that's going to be natural log, then it's going to be 1 over something to the first power, not something to the second power, and definitely not something to the y power. So how could we rewrite this before we go and take the antiderivative? Well, we would write that as a negative exponent. So we'd write that as e to the negative y dy. Then we'll go ahead and integrate both sides. Now the antiderivative of e to the negative y, well, we know it's going to have e to the negative y in it, and then because there's a coefficient on the inside part of that function, we're going to divide it by that coefficient, so we're going to divide it by negative 1. And ultimately we get negative e to the negative y. And then again, we want to take the derivative of this to make sure that we did it right. And we did do it right, because the derivative is negative e to the negative y times negative 1, which will cancel out that negative. And the antiderivative to the other side is pretty easy. It's just x cubed minus 3x squared. And then don't forget the plus c. If that plus c isn't there, you are missing out on a lot of points. From here, we have two options. We could isolate y and then plug in our point to find c, or we could plug in our point to find c and then isolate y. I advocate for plugging in the point and getting c first, because that is going to be an easier way to get a fourth or a fifth point, because solving for y tends to be a lot of algebra and a lot of mistakes. So get c first. So the next thing we're going to do is plug in 1, 0 into this equation and then solve for c. So we end up with negative 1 equals negative 2c once it's all simplified, and so c equals 1. We'll plug that back into our equation that we have, and now our goal is to isolate y. So the first thing we're going to do is we're going to get rid of this negative by dividing by negative 1 on both sides. So that just changes the signs over there. Then we're going to rewrite this. You can think of it this way. Take the natural log of both sides and then use the power rule of log. So this would actually say negative y times natural log of e equals natural log of all of this. And then the natural log of e is just 1. So you're left with negative y equals the natural log of negative x cubed plus 3x squared minus 1. And then from here, all we have to do is divide by negative 1 again. And so we get our answer, y equals negative natural log of negative x cubed plus 3x squared minus 1. Point values for these guys, differential equations, are always worth a lot of points, so they're so important to make sure that you have a good grasp of. The first point comes from separating the variables, so that just means that you correctly got the y's all on one side and the x's on the other. The next 2 points in this case are taking the antiderivative. So basically, if you got the correct antiderivative on the left, you got 1 point. If you got the correct antiderivative on the right, you got the other point. And then you get 1 point for having plus c, okay? And then you get 1 point for figuring out what c is. So c is 1 here, that's that point. And then 1 point for your final answer. I don't know why I have that there twice, but 1 point for your final answer. Now, real fast, if you forget plus c here, and you keep going and you get the right answer and everything, If you do not have the plus C here, then the most you're going to get is 3 points here, sometimes 2. You have to make sure that C is there. Otherwise, you're blocking yourself from getting any of these other points. The other issue, and it's even a bigger issue, if you do not separate your variables correctly, then you automatically get 0 out of the entire problem. And that is a huge issue. 6 points in this case goes a long way on the AP exam. So you have to make sure that you are separating your variables correctly. You have to make sure you know when you're supposed to separate your variables. I see a lot of people doing some weird things sometimes, and I don't get it. When you are solving a differential equation, when you're finding a particular solution to a differential equation, that means you're trying to figure out what y equals ultimately, and that means your first step is to separate your variables. So be very careful with that. All right, that wraps up our introduction to differential equations. So hopefully that made sense to you. We got a lot of practice in the next four problems, 4 FRQs. So with that said, you guys go ahead and give yours a shot. I just did 2000, what did I just do? I did 2013 number 6. Again, these are not in the order that we want you to do them. We are not going to do 2016 number 4 right now. I want you guys to do 2017 number 4, and this is a non-calculator problem. So set your timer for 10 minutes, and let's see how you did when we come back to the next video.